Okay, so for this video, we are going for a take political article, and this is not gonna be very technical, but more political. And as you can see, probably here, I will make this bigger. The title says it all. What if AI had corporate culture? So this is a fun one probably to read. It's probably a little bit stereotypical. Um, Gonna check out the author first. If we can do that, I'm not sure. CO 2026. Oh, here's it about me. Perfect. Hey everyone, welcome to my Substack. Currently flow at Bloomberg Beta, evaluating early stage AI companies and pushing the limits of AI. Love building, probably thinking around with something at this very moment. Tinkering out with something. I'm a rising junior at Yale studying CS and Econ. That says it. Oh, he's the same age as me, so this is gonna be fun. He's 1 year younger. Alright, so let's see what Alex has to say. How AI software engineering agents perform differently based on structure and interactions as big tech organizational charts. There will be more AI agents than people in the world. Mark Zuckerberg said that. Multi-agents are taking over. Research shows that AI systems with 30 plus agents outperforms a simple LLM call in precisely any task. Seeing more agents is all you need. Oh, interesting. Okay. Waiting for archive to load. I don't know why it's taking that long. We find that simply via a sampling and voting method, the performance of large language models (LLMs) scales with the number of agents instantiated. Also, this method is orthogonal to existing complicated methods to further enhance LLMs. So it's like everyone's saying, I don't know, something very different, like having a new algorithm, more parameters. I don't think better data, but I don't know, a logic engine. I don't even know if logic engine is something. But yeah, these guys were saying just put 12 in there. While the degree of enhancement is correlated to the task difficulty. We conduct comprehensive experiments on a wide range of LLM benchmarks to verify the presence of our finding and to study the properties that can facilitate its occurrence. Our code is publicly available here. Okay. Sure. In particularly any task, reducing hallucinations and improving accuracy. Well, how should agents actually work with each other? While exploring methods to improve AI performance on software engineering tasks, I stumbled upon an idea. What if we structured AI agents interactions like the organizational charts of big tech companies? Here are some key takeaways I learned after organizing groups of AI agents as if they were in companies like Apple, Microsoft, Google, Amazon, and more. Companies with multiple competing teams, competing to produce the best final product like Microsoft and Apple, outperform centralized hierarchies. Systems with single points of failure, for example, one leader making important decisions like Google, Amazon, and Oracle, underperform. So I guess democratizing these LLM models help them because the more they can vote on something, the overall effort is better. I don't know. Big tech organizational structures had a modest but noticeable impact on problem-solving capability. Software and big tech organizational theory. Previous attempts to improve AI software engineering capabilities included throwing more agents at SWE Bench, a popular benchmarking tool for AI software engineers. This SWE Bench. It's a benchmark, definitely. Okay. However, simply increasing the number of agents did not lead to dramatic improvements in resolution rates. See the SEMA agent. Okay. Can language models resolve real-world GitHub issues? Okay. Okay, there are some benchmarks, but I need to understand what they mean. And then there's SEMA. This is a result of running SEMA, Software Intelligence Multi-Agents, on the SWE Bench Lite framework. How can you make AI agents better as software engineer? 3 weeks ago, when I stumbled across a post by James Huckle about Conway's Law. Software and product architecture is denied to be a reflection of the organizational structure that created it. He presented an illustration that shed light on the dramatized organizational structures of Amazon, Google, Facebook, Microsoft, Apple, and Oracle, proposing the idea that just like humans in big tech companies, multi-agent communication structures could shape problem-solving approaches. I was inspired to put James' hypothesis to the test on SW Bench instances. So Amazon has hierarchical, Google is hierarchical, Microsoft are competing, Apple is competing, Facebook has this intraconnected graph, Oracle has more legal people and legal operations than engineering operations. Okay. The experimental setup. I organized AI agents as if they were in different corporations, evaluating 6 different organizational structures on a 13-instant mini subset of SWE Bench Lite to increase the speed of evaluation and for financial reasons. When building, what does this mean, man? When building the 6 the financial my bad. When building the 6 organizations, I based the multi-agentic organizational design off of some core observations. Amazon, a binary tree with one manager at the top level. To replicate this, I had a large number of agents that perform code repository search and a single agent that performed the repository update in the end. Google, a similar tree structure to that of Amazon, except that there are a lot of more connections between intermediary layers. I replicated this with aggregations of all agents' results within a single layer, passing that to agents in the next layer. Facebook, lack of a hierarchical structure, but still a web-like organization with many connections between agents. I modified the original agentic design by adding more possibilities for transitions between different agents. Microsoft, competing teams each with their own hierarchies. Essentially, I repurposed the structure in Amazon, decreasing the number of agents, and chose the best solutions out of 3 separate runs, each run having a small tweak to the hierarchy using a vector similarity voting method. Apple. I also interpreted this structure as many small competing teams, each with their own minimal structure. I used the same best solution method as Microsoft, except had many more runs without an agent hierarchy and different transitions for each run. Oracle. There are 2 different teams, a larger legal binary tree with a smaller engineering tree. I interpreted the legal team as the agents that are searching the code repository and retrieving crucial context, while the engineering team composed of agents that actually wrote code. The structure for both teams were similar to that of Amazon, with a single agent at the top coordinating information passing between legal and engineering. Results and software engineering benchmark Docker. To evaluate each set of patches on SW Bench, I used the Dockerized SW Bench evaluation provided by the SW SWE bench team. I've shared my results below. So out of 13, percentage resolved out of 13. Okay. Agentic corporate structures and SWE, SWE, it's not SWA, that's AWS. SWE performance evaluated on a 13 instance subset of SWE Benchlight. An analysis on organizational chart performance. Here are some observations I made on how different corporate structures affected performance. Competitive teams increased chances of success. The two top performers, Microsoft and Apple, both had multiple teams that were competing to resolve an issue, while other companies seem to have a... So did he like reinforcement? I don't get like how he did that, but fair enough. It's like take it in the abstract way. Seems like as always the intuitive answer is computing creates the best result and issue. While other companies seem to have one gigantic team generating a single patch, multiple teams allow for increased diversity of problem-solving approaches and increasingly the probability of resolving an issue. So do you have like multiple teams and then maybe, I don't know what he did. But maybe if I can go to the benchmark, the way he linked these things here, I can probably figure some interesting things out. Anyways, competitive teams increase chance of success. Okay, structures with single point failures didn't do as well. When I say single point failures, I mean companies with high level managers, agents that could completely alter the run results. Companies like Google, Amazon, and Oracle, a common issue when orchestrating interactions between multiple agents is the case where one agent fails, leading to potential issues where an agent could change the course of a team's problem-solving strategy. Companies with single-point failures are susceptible to this kind of issues. Additionally, the two top performers, Microsoft and Apple, happen to be the two largest tech companies by market cap in the world. It turns out the organizational structure that seemed to work best in the world also work well for AI agents. Alright. Looking at the results, the impact of different corporate structures on this mini benchmark was to be expected, a difference of 1 or 2 instances. In general, it seems that throwing more agents at an issue or changing the way those agents are organized, whether it's hierarchical or more connections between agents, will lead to marginal improvements in performance on a task. As complicated as software engineering, improvements performance on a task as complicated as software engineering. While more agents is all you need, found that accuracy increases by quite a large margin. 20%. Performance noticeably flattened after 30 agents on the GSM-8K. Maybe they could change Safari so it pops here, you know? Just saying. Alright, okay, GSM-8K is a dataset of 8.5K high-quality, linguistically diverse grade school math word problem created by human problem writers. The dataset is segmented into 7.5K training problems and 1K test problems. These problems take between 2 and 8 steps to solve, and solutions primarily involve performing this is an interesting website, Peppers with Code, using basic arithmetic operations to reach the final answer. A bright middle school student should be able to solve every problem. It can be used for multi-step mathematical reasoning. Interesting, okay. Grade school math. The research also found that tasks with excessive complexity, such as that in WE Bench, may exceed the model's reasoning capabilities, leading to diminishing returns on performance gains. I verified this finding in SIMA, achieving at most 2 or 3% gains over the best architecture with 40+ agents. And I anticipate these small gains would be consistent in the other non-multi-agentic architecture as well. In my opinion, bigger jumps in progress on the benchmark require a change in the actual logical reasoning capability of the agents, or their strategy and methods they can employ or are given to actually solve software issues. This can come in the form of more powerful base models, maybe GPT-5, or a wide array of tools given to the agents, be it a debugger, linter, what is it, linter? Linters, lint is the computer science term for static code analysis tool used to flag programming errors, bugs, stylistic errors, and suspicious construct. Interesting. Alright, so the term origins from a Unix utility that examined C language source code. A program which performs this function is also known as linter. Alright, so that's probably the software that gives you errors in your editor. Like when you're writing some when you're writing some Rust code or like Swift code, then it just tells you without compiling it that there's something wrong. I guess that's what this is. Okay. We were here. It's the same thing with companies. At the end of the day, if you're not hiring smarter employees or giving them better resources, their output won't improve no matter how you organize them or how many people you have. However, performance on 13 instances can be quite off from actual performance on the full benchmark, and the difference in just the mini subset are significant enough that it's worth focusing on. 50% increase from Google to Apple. Base models or tooling can potentially be limiting factors on agentic software engineering, but playing with agent communication structures, be it in a corporate organization or not, is an issue that absolutely should be tested as base models improve. As James Huckle put it, this concept could become a critical hyperparameter in AI agent design, with different organizational structures being better suited for different tasks. This concept could become a critical hyperparameter in AI agent design, with different organizational structures being better suited for different tasks. This is good. I mean, you can learn a lot from this. He goes over the benchmarks, which is great. And also, you could follow it very easily. I mean, if I can't follow non-technical, then I should probably not do this, Anyways, just scanning through this, so maybe we can fish something out. So that was just the grade school math AK examples, then 13 instances. So the 13 instances, he managed to have them in groups and in hierarchies, which is quite interesting if you ask me, but I would like to see a little bit more of code here so I know what he did. Because he's saying, while more agents is all you need, found the accuracy increased by quite a large margin. Performance noticeably flattened after 30 agents on the GSMAK. The research also found that tasks with excessive complexity may exceed the words using and leading to dimension routines. I verified this finding in CMI, achieving at most. Okay. Alright, so, I mean, the results weren't there. I guess he's saying that. But he's saying the way we put the agents together is a big thing, because, and this is probably engineering design, because you have to have an intuitive understanding of the problem, because sometimes you need a democratized answer, sometimes you need a dictator agent that tells everyone to just get the thing done. Sometimes, yeah, it depends on the task. So, but this is very interesting to know as a maybe in the few years we will have one of the biggest AI research areas will be how you how you orchestrate multiple AI agents. I don't know, but I hope it's less prompt engineering. I don't know. I hope it has more technical background to it. Maybe because you can have like your rigid structures of your company. So I feel like that's something that might become something, you know. Yeah, so the article was short, so we are going to finish this video now. But now I will put this in the corporate playlist, and then I'm thinking of going through the Y Combinator batches, different batches of different years, and talk about the what they are doing, figure out what they are doing, and maybe if we can maybe interview few of them. Who knows? But that's for other videos. Thanks for watching for now. See you next time.